Hey guys, what's up and welcome back to another video of Geeked on Science. So as you can see today we're going to be continuing learning about the periodic table, and today we're going to be learning about the transition metals. However, since there are a lot of transition metals and they're really hard to cover in one video, we are going to be covering just a few of them: copper, manganese, zinc, chromium, iron, and nickel, the most commonly used ones. So without further ado, let's get right on into it. So first of all, before we do anything, we have to learn the location of these metals, obviously. And the location of the transition metals is that they are located in the D block, and the D block is between groups 3 and 12. So groups are the specific way in which you address the area in which a element is located on the periodic table, but I made a more specific video on groups and periods and how to address the area in which an element is located, and I'll put the link in the description so you guys can go watch that one after you watch this one if you want to learn more about it. But now that we've learned the location, we can understand the physical and chemical properties. Let's start with the physical properties. The physical properties of transition metals are basically the same as all other metals, except that transition metals have higher melting points, higher densities, and they're harder and stronger. Higher melting points just means that they can withstand a higher temperature before melting, and higher densities means that they cannot float in aqueous solutions. And they are also malleable, but that's just that they're similar properties to most metals, like they can conduct really well electricity, and that when at room temperature they can be either a solid or a liquid, which is why mercury is a liquid at room temperature, and when freshly cut from the rock they're described as shiny or lustrous. Now that we understand the physical properties, let's quickly move on to the chemical properties. The first chemical property is the reactions. The reactions with oxygen are pretty rare because we don't really use transition metals that much, and they're found under the earth or inside the earth, and most transition metals still react very slowly even if reacting with oxygen, and some don't react at all, which is different from the alkali metals in which we learned, which are generally very reactive with oxygen. Here's the equation for when transition metals are heated with oxygen. An example is copper plus oxygen equals copper oxide, just like when alkali metals they create ionic oxides. Learn the reactions with oxygen, let's learn with the reactions with water. Like oxygen, the transition metals react slowly or not at all sometimes with water. And in case with iron, it reacts pretty fast in contrast to alkali metals, which are pretty mid-reactive with water because they're like different metals and have different chemical properties, but iron reacts pretty fast, causing rust. Now that we've learned that, we can learn about colored compounds and catalytic activity in the different transition metals. So let's get right into it. And this is also a chemical property I should tell you just before we start. So first thing we have to learn about is colored compounds. So transition metals basically form colored compounds, which are compounds in color, just like they sound. Now iron compounds can be green, brown, or red, depending on the other reactant. For example, when they react with chlorine, they're red. And the colors are actually a good way for scientists to observe compounds that are present in a substance. Like if iron red is present in a substance, then the color of the iron would determine if it's in the substance or not. And now catalyst. A catalytic activity is when the substance increases the rate of reaction without being used up itself. So that means half-life. Without using up its half-life, it can increase the rate of reaction, and some transition metals can actually be used as catalysts. For example, iron is a catalyst in the process to make ammonia. Now let's learn about some of the uses of transition metals, starting with copper. The most commonly widely used copper is used in electronics and in wires. It's also a good construction material, though many people don't use it other than to make pipes. And there's also a lot of copper components present in vehicles, like airplanes and ships, to stop them from rusting. which is why many things don't use actual iron, rather copper and other materials. So, next thing we're going to learn is actually iron. Now, iron is crucial for steel production and also has a lot of uses and applications in construction, engineering, and manufacturing. And did you know that iron is actually found naturally in the human body and is essential for making hemoglobin, which is a protein in red blood cells that transports oxygen? Thank you so much for watching, guys. I really appreciate my subscribers and all the support you're giving me. And if you do like this video, please like, share, and subscribe. And thank you so much for watching once again, and I'll see you in the next one.